Let's see. Oh, Levi, I was asked by multiple people if your Farragut West is a real project or just a training demo.
It was a project. It wasn't paid for, but it was a project that we did with a consulting company who was comparing it to Legion. So what we did was we took they were going between Legion and Viswalk, so we built out a Viswalk version, and so that's where it came from. So it did come from WMATA. We did have their actual data and site plans, and so that's how we developed the model. It's more of a demo model in that sense.
Cool.
But yeah.
Are there any standard practice to modeling areas? Is it desirable to model the largest area possible or have multiple small areas connected together and how that will affect the evaluations?
It depends on how you want to separate and subdivide your regions. So typically the way I will build out my model is based on uses. So again, the example I like to use is an airport, because everybody's gone to an airport and there's clearly defined zones, right? So there's the curb, the ticketing concourse, the security concourse, and then the gates, right? The actual gate concourses. Those I would do all as large areas, and then put dummy areas or smaller areas on top of that, right? So my curb would be one area, my ticketing concourse would be another area, but within that ticketing concourse, I'd have specific counter areas or routing areas within it. So generally, I would start with a larger area and then kind of add smaller areas on top of it. But I wouldn't do the whole airport as one large area. I would probably separate those out into smaller chunks, but have like one overarching large area underneath that we can evaluate if we want to pull out, for example, like the evaluation for the whole security concourse. If we have one
Mhm.
big area underneath, then we can pull that out.
Adding on to your answer, doing in several airports in the past myself, in Serbia, we built each level of the airport as a separate level, as a separate area, because if you use the DWG, the shapefile import tool, it's going to use the whole level as an import to an area. Now you can break that area down, but like Levi said, we stacked other areas on top of the area to do sub functions such as routing and that kind of stuff. And as far as answering the evaluations question, it really depends. You can look at it in multiple ways. If you're using area evaluation results and you use a gigantic area, the results will be washed out by all of the empty space. You can use something called sections to divide little analysis zones within the area, but then that's section analysis. So if you use smaller groups of areas, you can do more detailed analytics as far as density and queuing analytics within that area. But if you have a large area, you can use sections which is a feature of the evaluation criteria, to break sub areas only for evaluation analysis out after the simulation. Okay, questions are piling in. I got two questions, Levi, that are almost exactly the same. Are PEDs sensitive to the height of the obstacle? If it's low enough, will they walk over it? Is there a minimum height we should specify the obstacle so we won't walk over it? And many more versions of that same question.
So pedestrians do have a height component to them. When they're walking around, there is a height component to the pedestrians. They will never walk over an obstacle that is on their level. So if the footprint of the obstacle is 0, height, but it has a footprint and they're on the same level, then they won't pass over it. Now, where the height of the obstacle comes into play is if you have areas that are stacked on top of each other, like a column that might extend from the lower platform up through the mezzanine. If you make the column high enough and it extends into the walkable space of the next level up, then they will also avoid it. So that's where the height comes into play. Typically, I'm not worried too much about the height of obstacles. especially since I tend to use a lot of SketchUp files and other 3D files for visualization. So more often than not, I'm using the footprint than an actual height to it. Now the stairs themselves, and this might help if I jump into an actual model real quick. The stairs themselves also have a clearance underneath them. So you can see how this has a the stairs has like a little boxy footprint at the lower end. You can actually control what the headroom clearance is at the top and at the bottom. So there are headroom clearances that you can put on staircases to prevent pedestrians from walking under the staircase too close and things like that. And so under installation, you can put ceiling headroom and foot headroom and control that as well. So from an obstacle perspective, they will never pass over an obstacle as long as it's on their level. From a ramp perspective, you can control where they can pass underneath obstacles and things like
Typically, I will make my SketchUp obstacles invisible by using by designing a custom display um, feature that is invisible, and then I'll give them a height of 0.1 feet just so I can see them in 3D, but they'll be
that. Yeah.
completely invisible as long as they're there. Okay, let's see what else. How do you calibrate a pedestrian model? Are there any FHWA calibration guidelines for us to follow?
There, as far as FHWA, I'm not familiar with a whole lot of that guidance from calibration. Typically, the calibration that I've done has been mostly on the volumes and travel time side. So for something like Farragut West or Sunset Transit Center, which is what we were building out here, we did do an actual project there using real data as well. More often than not, that was a matter of building out your base model and making sure that the pedestrian arrivals and things like that were accurate. For example, for Farragut West, we didn't have door counts. What we had was turnstile counts and then boarding and alighting counts. And so what you kind of have to do is reverse engineer things like pedestrian flows and arrival times, and then you go out and you measure travel times from the doors and things like that to kind of calibrate the model. So as far as that goes, maybe Sean knows a little bit more about uh, industry guidance in terms of
Right.
professional guidance, but
So I should, I
that's
mean, I
how we.
should, before joining PTV, I did a lot of this stuff for 10, 12 years, and I have never personally come across a federal pedestrian simulation guidebook. That's not saying it doesn't exist. One group may have created it or not. Generally, a lot of it is just establishing your own criteria with your client and that you're okay with as far as calibrating density. I mean, Viswalk works just the same way in Vissim, where you can extract anything you want as far as queuing and delay and trajectories, whatever you need to do, and you just need to establish it. And also, from my work in Europe, there was also no guide for pedestrians. There are a few companies that do cycling in pedestrian zones, but not pedestrians specifically. So. Hopefully, as pedestrian modeling gets more accepted as widely as vehicular modeling, it will become a priority. I know we're getting towards the end of the time. Let's see what else we have. Is it possible to control elevator capacity?
It is, and that is a measure in the elevator groups themselves. So when we come in to something like a model like this where we put in elevators and we define our elevators, here we have a capacity for the interior of the elevators themselves. Now that can be partially defined by this listing. So this is kind of a hard capacity from the perspective of, you might have a sign posting inside the elevator that says no more than 12 people, right? But if the spatial component doesn't allow for that capacity to ever be met, then there's always going to be that inherent capacity with the geometry of the elevator. So if you build an elevator that's 1 meter by 1 meter, you're not going to fit 10 people in there, kind of thing. So even though, yes, you can define a capacity so that when 10 people load in, an 11th wouldn't load in even if there's room for them. There's also that geometric capacity that you have to consider as well.
Yeah, and just quickly adding to that, I can tell you from practical experience, if you tell it only 5 people can get in the elevator and there's a whole lot of space, they, excuse me, is a lot different than if you make no space and then tell them 10 and 10 people come to the elevator, they will continuously try to stuff themselves in as long as it's possible. So that's something to be, these features here within the elevator groups are very important to understand as far as the realistic representation of your situation. Okay, I know we're getting over time. Let me see if I've missed anyone. Do you know if there's a .dgn file import in addition to DWG, shapefile, BIM, and all of that kind of stuff?
I don't think that there is a DGN import. I think it's just BIM, SHP, and DWG are the only ones that I can think of off the top of my head.
Let me see if
yeah. Oh, go
Go
ahead.
ahead. No, it's fine.
I did see one question about what is the maximum number of pedestrians we were talking about, and the response was 30 pedestrians. That's the default, but if you do end up getting the Viswalk add-on to your license, you could go up to as many pedestrians as your computer can simulate. So we've run simulations with millions of pedestrians running at the same time. It's just a matter of how strong is your computer and what license level do you have. But the default Vissim license only has 30.
He was answering on to all of basically the answer, the overall answer to the 3 separate questions that were related was that all of the components you see down in the bottom left, the ones that are all yellow, are built into the software. If you have Vissim, it will be there. You can use it, you can interact it, you can train with it, but in order to make, Viswalk is an add-on, so that is just an introductory, and it has a 30 pedestrian maximum, 30 pedestrians in the model at one time, not throughout the whole simulation. And then you can buy add-on license for, there are subscription and perpetual 5,000, 10,000, 50,000, infinite, millions. So if you have interest more in that, please contact us separately. We can talk to you about licenses.
Yep.
All right, the last 2 are softball to you. Is there going to be a recording available, and when, for this presentation?
Yes, there is a recording available, and it will be posted to ptv.to/learn. So again, if you are interested in getting that recording, you can go look at it there. We'll also be posting the PowerPoint and some example files as well at that location. So if you want to go through this presentation again and things like that, you can follow along.
You've been asked to push play on a model so that they can see what it looks like while it's running.
Okay, yeah, that's easy. So here is the model that we built. I just need to save it. I'll just do test real quick. And then we can just hit play right here. So error. Oh, it's because I have different levels. All right, well, there we go. I'll just run this guy. I know this one runs. Ignore. And crash. Okay. This is why you always save your work. Let me come here. I'll reopen up my Farragut West model. Okay. Live demos, it always crashes. It's just the nature of being a live demo. All right, yeah, so here, let me actually turn off my evaluation configuration just because that might save some processing power. I'm gonna hit play on the simulation. It's gonna initialize, and then the pedestrians are gonna start appearing at different locations. So let me just turn on all these different things. So here, during a simulation, let me turn off the 3D objects so you can actually see what's going on. We have trains interacting that are boarding and alighting pedestrians, and then we can see how they are moving between their platforms, and then they're
You,
going
al-
through
you
there.
also have live density analysis on as well, so you can see how the different pedestrians are different colors depending on their experience density in real time.
Yeah. But yeah, so the trains will, if you're interacting with Vissim, this is why we always, recommend adding it onto Vissim rather than getting the standalone, because then if you're modeling any sort of public transit or anything like that, it will also generate pedestrians. And you can see here how the escalators are actually moving up and down. We have different time intervals for the pedestrians to show up and depart.
Can
And
you
so,
slow the swiping a little bit? The internet's
yeah,
making it really
yeah, go
jumpy.
for it. Yeah.
No, I meant like moving back and forth really quickly. The internet's making
Yeah,
it
yeah,
really
yeah, I'll
jumpy.
do that. Also, slow down the simulation so you can kind of see pedestrians moving a little bit better. So pedestrians do have a height component. In this case, they have multiple options to pick from between the different escalators, and they're just picking whichever one they think is the best. Similarly, we didn't have elevators in this model when we built it a few years ago. So, but if there was an elevator here, there's supposed to be an elevator shaft right here. They would also pick between the whether to take the stairs or the elevator on their own. You don't have to determine the percentage of people. You can micromanage them, or you can kind of leave it up to themselves, right? So I could micromanage which percentage takes each one of these up escalators, or I could just leave it up to the pedestrians. It just depends on how much detail you want to go into in terms of the pedestrian modeling.
Micromanagement helps quite a bit when you're doing much more stringent things like airports. You know, you must go this escalator to customs, or people with disabilities must take the elevator instead of the stairs. You can force that kind of micromanagement.